Welcome back. In this lecture, I want to derive an identity, which is the sum over the first n Fibonacci numbers. So what we want to do is we want to find a formula for f1 plus f2 all the way up to fn. The notation of writing that is a sigma notation. It says the sum from I equals 1 to n of f sub I. Okay? So what we're going to do is we're going to try and discover the formula, and then as mathematicians I will show you a direct proof of the formula once we've discovered what it is. Okay? So to discover the formula, we write a table. So we have here the n equals 1 through 9. And then we write down the first 9 Fibonacci numbers, 1, 1, 2, 3, 5, 8, 13, etc. Okay? And then in the third column, we're going to put the sum over the first n Fibonacci numbers. So the sum of the first Fibonacci number is 1. It's just f sub 1. The sum of the first 2 Fibonacci numbers is 1 plus 1. So that will be 2. The sum of the first 3 is 1 plus 1 plus 2, but actually all we have to do is add the third Fibonacci number to the previous sum. So we need to add 2 to the number 2, so we get 4. And then we add 3 to the number 4 to get 7. And then we add 5 to the number 7 to get 12, and so on. So we can get the sum of the first n Fibonacci numbers. Okay? Then let's look at these numbers. What do we have here? We have 20, 33. We look at the Fibonacci numbers. We have a 21 and a 34, so that looks promising. 34 here, 33. 21 here, 20. 13 here, 12, 8, 7, 5, 4. So this looks like a general rule that we can take the sum of the first 6 Fibonacci numbers looks to be related to the 8th Fibonacci number minus 1, right? 1 less. So we can write that as a formula. So our conjecture is that the sum from I equals 1 to n of f sub I is f sub n plus 2, right? 2 more than the last Fibonacci number the index 2 more than the last Fibonacci number that we summed, minus 1. Okay? That's our conjecture. So how do we prove something like that? Okay? Let me use black ink here. Okay, how do we make a proof of that? The only thing we know about Fibonacci numbers in this context is the recursion relation. So we can write down a recursion relation. There's an fn plus 2 here, so let's write down the recursion relation for fn plus 2. So fn plus 2 equals fn plus 1 plus fn, right? So that's the Fibonacci recursion relation. But we can rearrange this formula. The left-hand side is going to have an f sub n, the last term in the sum. The right-hand side has an fn plus 2. So we can try to write this as f sub n equals f sub n plus 2. Then we have to subtract f sub n plus 1. Okay? And that would be the last term in the sum, the f sub n term. But we need to have all the f's in the sum, so we need to go back 1, so we can reduce the index by 1. So we can write down n minus 1, f sub n minus 1. This is 2 more than n, so this should be f sub n plus 1, 2 more than n minus 1, minus, this is just 1 more, so this should be f sub n, right? And so on. Let's do one more just to see. F sub n minus 2 equals f sub n minus f sub n minus 1, okay? And the idea being that we're going to have all the f's here, so we can keep going down. And then the last one will be our f sub 1, our first term, right? And then this one will be 2 more than that, so this will be f sub 3 minus f sub 2. Okay? So we have now on the left-hand side, we have all the f's that we want to sum in the expression. So we can take this and then we can add them all. So there's a big plus sign here. Okay? That's the idea. But look what happens when we do that. Let me change the ink color to red for the moment. We're summing these equations, but look, we have fn plus 2. Where am I? We have fn plus 2 minus fn plus 1, and then we have fn plus 1. So when we add, we get minus fn plus 1 exactly cancels fn plus 1, right? We have a really nice cancellation there. And it continues, minus f sub n cancels f sub n. And all these terms cancel, right? So this one cancels against 1 here, etc. Then finally, going all the way down, this one cancels against this one. So we only have 2 terms left. We have exactly 2 terms left. Let me write that. Go back to black. So what do we get at the bottom? We get the sum on the left-hand side. We get the sum down here. We get the summation of our f sub i's, right? The sum from I equals 1 to n. Let me not write that. And then we have 2 pieces left. We have fn plus 2 minus f2, right? Only 2 terms remain. The identity says f sub n plus 2 minus 1, but we know f2 is equal to 1, right? f2 is equal to 1. So by making this list, then, we've managed to prove the identity, okay? In the next lecture, I want to kick it up a notch. Instead of looking at the sum over the f's, let's look at the sum over the f squares. Okay, the sum over the f squares. I'll see you next time.